Good evening. Thank you, Karina. Thanks for to the Azure team for the invitation. I will tell you a little bit about myself. I work for Unisys, which is a global company. For some time, I was responsible for security solutions across the company. I'm going to tell you a little bit about my attitude about security and why I think information security can be kind of a frustrating thing to confine ourselves to, and why I think we open it up to a wider perspective. I define security very broadly. My background is in software development to high availability mission systems. Spent about 15 years doing work for the FAA, designing and building the FAA's remote maintenance monitoring system. It's the only NAS subsystem with no backup. The requirements for 365 by 24 availability with no more than 3.5 hours a year of downtime. We didn't fail to meet that requirement in the first 10 years of operation. That's what I think we need to do. Build large-scale distributed systems that don't fail. And that had self-maintaining databases. You can imagine we actually budgeted our 3.5 hours a year of downtime to daily momentary snapshot backups. So we would freeze the system on a daily basis just in case our audit trails failed. To me, if we're going to build a system that doesn't fail, it has to be able to do degraded mode operation. That, by the way, is the system fictionally hacked in the movie Die Hard 2. It was not, in fact, hacked for real life. Since September 11th, I've worked a lot in national security, was involved with TSA, the stand-up of the TSA infrastructure. We learned a lot about rapid ATOs there. We're going to talk a little bit about that later. We also learned a lot about setting up a cloud an application stack and setting up an infrastructure environment that allowed us to build on those with what we called back then type accreditations. With the world of A&A, it's a little different, but not overwhelmingly so. So I'll share with you a little bit of that experience. And what I want to talk about is really three subjects. What does security mean to me, and how do I see it evolving for our federal agency customers? Two, a little bit about the federal IT modernization program as it relates to security, because it touches on some of the themes from this evening's agenda, but also, to me, is pretty narrowly defined and pretty tactical and tight in a time frame. And then a much longer run view of why I think some of us are entitled to be optimistic about the future of our society. That happens to be the message I want to share with you. I'm a big believer in that. You will probably not believe me, but that's okay. Would you go to the next slide, for the first slide? So there are 6 slides here. These are the subjects. Step back up one, please. I don't know. Okay, well, it says 10, but it's my first slide. I don't want to be given credit for the wrong numbers. You guys can hear me okay in the back, right? Okay. So, Michelle, please go ahead to the next slide. Thank you. So, Unisys is a global company. We do global surveys of consumer attitudes about security, and we don't limit it to information security. You probably can't read much of what's on this slide, but we ask questions about financial security. Are you comfortable with your financial future and your financial records? We ask about counterterrorism and the threat of terrorist attack. We ask about health care, like epidemiological threats, as well as internet threats. And what we found is 2/3 of people in every country in the world that we survey tell us that more than any other issues, they're focused on identity theft and misuse of their credit cards and personal information. And what comes next is internet crime. This is most of the people in the developed world in different cultures. We care about this as a company in part because we design security systems for banking customers, for government customers. And the question is, do you put the security up front or do you hide it? And if people are looking for security, they actually go to a different bank in Latin America based upon whether their account holder data is going to be protected. It's a differentiator to have security be visible, to show what you're doing. Biometrics, well, I won't tell you about individual accounts, but they ask us the question, what is the DoD doing around identity protection, biometrics, protecting account holder data? Is a similar action to them? How do they do multi-channel identity fraud for in-person, on the phone, and the banking that occurs in various channels across the internet and mobile phones? That's actually what industrial and commercial customers are thinking about, not just inside the beltway, the government. But why don't we keep going? So I'm going to, the next slide, if you don't mind, Michelle. I assume you guys can read the slides if you care to. I'm not going to read them to you.
I'm not sure the camera can follow you, so
Does that mean I have to move?
yes. Sorry, Mark.
It's okay. Well, I just didn't know if it was.
I was on the internet watching you.
I didn't realize we have this. This reminds me of the time I did a radio show, and they did tell me that they were filming it. And everybody else in the panel, they act presentable, and I'm sitting there reading my notes, scratching my head, thinking, gesturing, And anyway, sorry. I didn't realize it was a live stream. I apologize.
There you go.
Okay, but the question still stands. Can you guys read the screen? Okay, so those of you in the room, I'm not going to read it to you. Those of you in the cheap seats, I'm sorry, but I'm not going to read it to you either. But there are a couple things in here that are worth mentioning. That cybersecurity and IT is evolving. This business about augmenting and replacing perimeter protection with identity services and encryption has been an issue for years. Everybody in this room, I'm sure, is aware of that general trend, that the perimeter is moving, that we now have cell phone applications across carrier networks. But this is something which has been evolving in a way that if we talk about the tick, this trend and the tick aren't going in the same direction. About 50% of the traffic crossing the tick right now is encrypted and not subject to inspection by Einstein 1 and 2, so it's kind of pointless. But well, let me rephrase that. So those in the government, out of respect for you, it's not accomplishing the objective that was originally intended if it can't inspect those packets. But this whole thing about continuous adaptive risk and trust, moving to hybrid IT environments where we have on-prem and cloud-based applications, and service integration across agencies, these are challenges facing our federal customers. Meanwhile, we're moving to the cloud, we're moving to mobile apps, IoT, and I have a particular pet peeve about how we're going to protect AI environments in the future that I'll come back to. But there's three thoughts I loved from a MITRE summit on cybersecurity. One was that Gartner says this, but also Dr. Ron Ross, and everybody here knows who Ron Ross is, right? The founder of, out of NIST, the primary author of FISMA, primary author of the FISMA implementation documents. Ron's a great guy, former military officer. When he shows up, he wears a suit and tie like me, unlike the rest of you. But thank you. You make me feel better. But the point is that he's an optimist about securing our IT infrastructure, but he says, assume you're breached, assume you've been penetrated. Verizon breach report tells us the average incident is 240 days before it's known. So this is really the issue, the importance of business resilience during a penetration, assuming you're breached, having the protection of your high-value assets. I like Steve Tremidze's comment, cybersecurity should not be the responsibility of the users of technology. Steve's the former in Justice Department, the head of cybersecurity there, of cyber enforcement there. And Phil Reidinger, who used to be responsible for NPPD, said if you're not in the IT business, get out of the IT business. In other words, go to Azure, go to Office 365. If some law firm is running Exchange and Prem, what the heck are they doing? Why? But these three things are driving the industry and should be driving the decision-making around cyber. So let's go to the next slide. And do all the builds so people can see what's here. I'm going to suggest that there's really 4 building blocks to a secure IT infrastructure. And if there's nothing else you get from what I'm going to say, I want to share this thought with you because I take this very seriously. Identity, whether it's across the internet, whether it's in person, whether it's in the internet via email, or if it's some asset that's acting on your behalf, is a vital property, the attributes of identity, which we aren't doing a good job dealing with across our society, but we all know what's going on here. We all, many of us have more ID cards than we know what to do with. It's not because we have that many multiple personas, it's because we have that many organizations we're dealing with that don't have any kind of method to share identity data reliably. And it's something that, at least at the enterprise level and across government, is a necessary thing for us to have a trustable internet and transactions that we know we can act on and reliably deal with from a non-repudiation standpoint. I'd like to talk about trusted devices because any endpoint on the network, any edge device, whether it's a gateway, whether it's a phone, whether it's an IoT device or sensor, it could be a weather sensor, we have to trust it. If we're going to get weather data from a sensor and it's the wrong information or it's corrupted in transit, that could mislead us to the point where we send a fighter aircraft expecting cloud cover into clear sky, lose a pilot. Or we send a commercial airliner into a bad storm when he's supposed to be flying around it. So even something like weather data, which seems like it's not so sensitive, it's certainly not disclosure sensitive for the most part, except for the sensors in Air Force One. Even that, there's a lot of sensitivity about alteration. And we don't generally think of at that level the way that we might. There's a future, a lot of investment in trusted devices. Intel, other companies spending a lot of money on this, trying to get to a true trusted execution environment, trusted boot, measured boot. For IoT alone, this is obviously a big challenge. And then trustworthy services, which to me is something like the Azure stack or any cloud provider, to come in and say FedRAMP. But it's also the apps behind the scenes. The mobile apps on our phones depend on cloud services to get their data. When we look at a weather app on our phone, it's actually getting data from an app service in the cloud. We tend not to think of it that way, but we're trusting that. Our banking applications are in the cloud. So what we're really doing when we even use a mobile application is depend upon data hidden behind a service, often running in a remote facility. And to me, that's generically a trustworthy service. So I'm packing data inside the app on top of a platform that to us we just deal with as an abstraction layer like a microservice architecture service. But that could also be an industrial control system like the system that manages a pipeline. It could be a managed service provider like a security operations center. That's a managed security operations center. Trusting those services is our biggest challenge right now. But connecting all that, what we need is trustworthy connectivity. And I would argue it should be invisible to the user and automatic. We shouldn't depend upon the user to know anything about it, but it has to cross all the boundaries of the domains we just were talking about. So something like a VPN works inside the enterprise, but we need something which goes all the way out to the mobile phone, all the way out to the IoT sensor that can protect the traffic when the ICS or SCADA system is dealing with a sensor in the field. But when the central control node is down, which we have with the FAA at times, how do we have the remote technician from his home be secure when he directly connects to that remote sensor to take control? That's the challenge we have for trusted connectivity. And I don't think that challenge is too far out of our grip. In fact, there are tools that allow us to do it today that are highly secure. My point is, this is kind of the topology that we need to think about. Obviously, I left out security management and risk management, and that's around this with different zones. I'm going to pause for a minute. Does anybody want to say how much they admire this chart before I move on? Thank you. I appreciate that. How are we doing on time? Okay. So let's keep going. This is a chart that I did for federal agency customers. And kind of what do we think they should be thinking about as they move forward with infrastructure and supporting a secure future. The dominant issue for our federal agencies is they have mission systems that are brittle, that are put together over a long time, that have interfaces that were assembled generally quickly, but then put into production and not necessarily made as robust as they might be. We tend to have them all chained together, often with batch data transfers as the original model, now with queries that are going on across links that when they go down have a cascading failure effect. I don't want to talk about individual agencies here. There's no point in trying to act like a game of gotcha. It's a general problem that most of the federal government agencies that have been in business a long time have systems that are out of date. And that the staff is overstretched. What they're trying to do to maintain them and then improve them has been a challenge. Every business system we have across the country has some of the same issues. But most of our businesses and most of our government agencies no longer have paper backup. So we've gone, in my lifetime, from a world where generally we had paper-based business systems with computers used to summarize and report and be able to feed decision-making, to systems where the transaction flow of the organization now depends on the automation environment. And after a period of time, the paper-based system erodes. It doesn't have the latest changes for compliance or regulatory or scale, so it no longer functions. And all we're left with is this, maybe it was client-server, maybe it's something else, but we have business systems we depend upon that weren't designed for the high availability the organization needs. And generically, that's a security problem to me. Maybe you call it a mission assurance problem, not an information assurance problem. I don't care. The bottom line is business resilience is the vital question. If we keep going, migrating to the cloud and data center transformation go hand in hand. But automated operations is really the goal, as everybody here knows. If you can read the slide, I'm not going to read the words to you there. I happen to think that identity and access management is one of the few good examples where federal agencies are saving money and improving mission outcomes from investments in security. We've done surveys that support that. For those of you that are security professionals, those surveys tell a story about successfully delivering value, mission value, reducing cost, and reducing disruption to operations by making investments in security since HSPD 12 back in 2004. Not everybody's a big fan of smart cards, But the truth is that the infrastructure to use them in the context of secure logon on the network has resulted in operational benefits that are substantial and across many agencies. It's not fully automated, it's not all federated, it could be better, but my point is that delivering on those benefits is still a challenge to fully capitalize on them. But we have some other things with biometrics, behavioral analytics, distributed trust using blockchain. What does identity mean in the future? Can we harness the blockchain initiatives around travel security effectively? Does anybody here know what IATA is doing with blockchain for passports and biometrics? Okay, I'll give you one of my nice examples of the government working. How about traveler verification service, the check-in, facial recognition used for check-in for international flights? Are you guys familiar with that? So CBP has rolled this out, cloud-based, a phenomenal success story. The airlines love it because they can board planes at half the time. Travelers find it more convenient. They don't have to fumble around with boarding passes. CBP provides the back-end facial matching. For international travelers, we have a repository of visa photos and passport photos, so we have a photo for 98% of the travelers. The only travelers on international flights that we don't have photos for are active duty military. Everybody else we can match with high levels of confidence. It's been a phenomenal success, and it's the private-public partnership making it happen. By the way, if you enroll in the registered traveler systems at DHS, you go to logon.gov, a GSA initiative around single sign-on. But how did I get here? Blockchain, sorry. IATA has an initiative to eliminate the need to carry a passport. It's called One Identity. IATA is the International Air Transport Association, working with the folks at the UN and ICAO. It's around the idea that a blockchain will store your biometric template, that when you appear, it will be able to unlock that segment of the blockchain and have your traveler information be visible to a trusted party. So it's a permission blockchain, but the enrollment and issuance would be by passport authorities in various countries. But by storing your personal data there in a way that's not easily compromised unless you unlock it with your biometric template, you now could walk through the airport, be verified without your passport. And so it's taking this facial verification approach, adding a blockchain infrastructure underneath it as a potential international travel security. So one could say that what's going on in this world is pretty interesting. And what it's really delivering is a secure system where security isn't the sole objective. The objective is actually delivering information value and agility. And I sometimes like to ask people, I'll ask you, why do we do security? Or I may ask a different question. Why do we have brakes in our car? Okay. Who has an answer? Why do we have brakes in our car? Go ahead.
So we don't crash into the thing in front of us?
That's part of it. But keep going. Does anybody else have an answer?
So you can go faster.
Exactly. Yeah. The day that my brakes on my motorcycle didn't work, I can tell you I did not drive fast. And that's really the point of security, is to allow mission owners to accomplish more with mission delivery systems. Get them out closer to where the information can be captured and used. Deliver information securely out to the front line. If we can't deliver that information securely, we don't share it. So ultimately, the value of security is not compliance. Compliance is kind of sad and negative. It's really about enabling mission outcomes and being able to deliver across less expensive, more flexible vehicles. And to me, this whole traveler verification thing is really an example of that. Or improved security, because we can now do biometric identity matching for people leaving the country, which was a congressional mandate. But we do it in a way the airlines save money and travelers like it better. So it's using security as an enabler to deliver a better mission delivery approach. By the way, the CBP officers even like it better, because they can spend more time focusing on the bad guys. And they get a lot of good information about the bad guys that they get through an automated link, because we can do that. We can give them that risk score in near real time along with the face matching. I won't tell you about the guy that was recently caught with the face matching at the airport, because we're going to keep going. A big pet peeve for me is physical-logical convergence, physical security systems tied to logical security. We built some systems like that for banks. We did it for airport authorities. FBI came to us and said, we have people logging onto our VPN from when they're inside the office. We want to disable the VPN when they show up and they badge into the building. We want to enable it only when they leave. We want to enable their network logon only when they're in the building. We don't, and that sounds kind of simple, but it's not an easy and straightforward thing to have done 10 years ago. But it's the sort of thing that we can do relatively easily and straightforward if we have the right tools. But there's also what I call industrial-grade IoT, forgetting about the refrigerator that talks to the cloud and orders milk for you, but real safety-critical systems, like law enforcement, life and safety systems for IoT, and ultimately the consumer world of virtual reality. But distributed artificial intelligence is really what I worry about. And that chart I showed you a moment ago, we had secure, trustworthy services, trustworthy devices. How do we make sure our devices that are on the edge, when they're activated based on deep learning at the center, are getting the right instructions? How do we make sure that our smart city, or my smart car in the future, I have a daughter. If my daughter's boyfriend on April Fool's Day wants to send me somewhere else by hacking my smart car, that's not a good thing as far as I'm concerned. I want my smart car to listen to me only about where to take me. Ultimately, that's the problem to me of distributed artificial intelligence, that we're going to put we're going to execute the intelligence at the edge with sensors that are smart, but we need to then learn at the center and be able to get the updated rules out to the edge. And if you think about distributed like industrial control systems, it's the same issue. Does the pipeline control system that says put the pumps into test mode and overrun them at 160%, is that a valid command or not? That's what blew up the Russian pipeline in Siberia back in 1987, causing the largest non-nuclear explosion ever in the world. It was a spurious signal coming from a control station. So we already have examples of this being an issue. But let's keep going. So, next slide. I want to talk just a little bit, and I've got 2 minutes left, so it will be a very little bit, about the report to the President on federal IT modernization. Can I step to this side of the screen?
I think so, yes.
Okay, thank you.
You're allowed.
I want to point, assuming you guys can read this, and you can get this report, and the link is there. This was in mid-2017. But you'll notice that one of the key objectives was for network modernization and consolidation to modernize the TIC and to enable cloud migration by doing that. That's one of the topics we're going to talk about today. There are some interesting issues that were raised in this report that is worth looking at, even if it might be a little dated. And of course, the other thing was shared services to be able to move towards a future network architecture that's in the cloud. What did they focus on? Automation and outcome-oriented security, a data-centric security model in the cloud instead of focused on just protecting transmission, and some of the challenges around perimeter-based security. Like I mentioned a moment ago, the fact that a lot of the traffic is encrypted, so you can't inspect it on the boundary without a different model for how to do that. Do all of you know what the trombone security model is? Where some of the agencies have gone to the cloud, but between the cloud and their on-prem, they throttle the traffic by having all the outbound traffic from the cloud go through the on-prem system and then through a TIC. So they end up with the slowest possible performance and frustrate the hell out of everybody. That was documented in this report. But I want to talk about a more optimistic future. Go to the next slide, please. This is something that most people don't know about and haven't heard about. But there's a vision for how to achieve a safe and secure internet for critical societal functions, not consumer-oriented, but things like national defense. Our Defense Department is the first responder of last resort anywhere in the world. How do we deliver on that vision for all the people that are stakeholders around the world? How do we deliver safety-critical systems like water and wastewater? The NSTAC, which is a private sector organization, it's under the FACA, the Federal Advisory Commission Act, advises the President and is working on a concept for this cyber moonshot. The goal is not something that can happen right away, but the goal is to lay out what will it take to achieve a secure internet for critical functions. And what I'm going to suggest to you is this is not within our grasp, but it's an aspiration that we can achieve. And the federal government, as leading a whole-of-nation approach, is in a position to do things that we sometimes forget we're capable of doing. But the same federal government that could migrate from analog to digital TV on schedule and not disrupt grandma and grandpa's TV broadcasts can do this too. You'll see some of the words up here around some of the things that are being looked at. Rather than take the time to go through this, let me just say that the attempt is not to make it sound easy, but rather to achieve a significant step forward in what we can deliver to the public. And if you look at the President's management's agenda, it's really about delivering better systems for the public. That's our collective goal. I think that's what we can do. If it takes us 8 or 10 years, many of you will still be alive to benefit from it, but our job is to turn over a safer and more secure, connected world to the next generation. And that's really where we are. Anyway, thank you for your attention.
Do you want to take a few questions, Mark? Are you going to allow that?
I'm happy to take questions, one of which is...
We got one in the back. I'll give you the mic. And
Okay.
Oh, good evening, sir. Thank you for coming out. You've talked a lot about technology security and to some extent, trust that's built up in the core, let's say. But have you got any commentary about, people of malintent, shall we say, that end up working inside the government, that work inside industry, and that somehow are able to skirt around these things and somehow from the inside do things?
Well, yeah. The insider threat, in a classic sense, has been with us a long time. I mentioned that some time ago we had a project for a top 5 World Bank to integrate their physical and logical security within. This was within their international funds transfer operation. They had a trader that was skating along the seams of their their risk management systems, and they saw Societe Generale had lost $9 billion the year before from such an act. And they realized the Russian organized criminals were eavesdropping on their operation using Wi-Fi. So this is the sort of thing that people around the world are very much aware of. And the idea of being able to correlate threats across logical, say in this case it was an ARC site, SIEM they were using, physical, and we set up man traps with biometrics on the way in and the way through. We had desktop authentication with biometrics. We took a photo of the people that were not allowed entry so that we had forensic grade information, and we captured the prints as well, or the irises. So we had forensic grade information for the suspected imposters. The number one issue is we have to treat physical security and risk management the same way we traditionally in the past treated IT security. The most valuable information we have is the audit trails around unsuccessful attempts and what was the data presented. And traditionally in physical security, that's never done. When you go to physical access control systems, you put a fingerprint down, it's usually a slow serial device, and they don't bother to collect the print. They collect a template, match it. If it doesn't match, they say, we turned you away, and they did its job. Great success, which is nonsense. At that point, that print is the most valuable information we have about a person who's casing the joint or trying to get in. Could be an employee, could be an insider testing the limits. If we can get a face so we can actually know who it is more reasonably. But that, to me, is kind of the challenge. That's why I talk about physical and IT security convergence, because I think that ultimately those payloads or that information is the most valuable to us. But certainly there's a lot of investment and activity around insider threat. I would argue that one of the most important things to do is segmentation of your network. To segment, whether it's VPN or other technologies, so that if somebody is in the HR department, it's not easy for them to traverse over and look at, say, information that's in some other department, like maybe intellectual property. Now, part of it is not just insiders, it's also when somebody hijacks that machine, a malicious actor even from outside. You don't want them to traverse the network either. So the same control can help you with both. I don't know if that helps, but that's, yeah, I don't mean to minimize the importance of it, but by the same token, I would argue that if you focus on identity and you focus on trusted connectivity and you segment your network with high-value zones where you can't traverse them even if a bad actor takes over your machine, that does a lot to provide you with protection during a breach. And I would say that that should be the minimum. That's my view, at least.
Any more questions? So we can take one more. We've got one back here.
Or it could be comments. We'll take corrective feedback. Yes.
Good evening, and thanks for your presentation. Ted O'Connor, the CTO here at FEMA within Homeland Security. And
thank you for making the personal sacrifices that you make to help protect our world.
Thank you. And just thinking about your work at FAA, we partner with you guys, and when you were at FAA, and we tell people, as tragic as 9/11 was, it was also one of the greatest miracles in government service. And what was that? It was the fact that after the event, every single plane that was midair was landed safely in U.S. airspace. And you saw that famous map where it was completely black. And this is all international flights in. Not a single plane was lost, not a single fatality. And a lot of people don't recognize that. So we work with FAA, so your colleagues there. Here's a question related to what you just said about segmentation. If you know anything about Homeland Security, we have something called OneNet.
Right.
And we're now in the process of consolidating our security operations and so forth. So how do you balance off the idea of visibility within your security boundaries, and how do you define them, and yet get to a place where you're segmenting so that we can get into models that, in terms of secure services, your first slide, where these services are trusted. In other words, they're role-based, immutable, and least privilege, right? So typically in secure software, we're moving in that direction. So how do we get to the future where we might want to continue the process of having a one net? Yet, on the other hand, you seem to be indicating, and we agree, at least I do, that network segmentation is really critical. How do you balance that?
Forgive me, because I didn't explain this, so I'd appreciate the question, so I may. But by the way, before I go on, let me just say I've not worked in the FAA for quite some time. On or about the time of September 11th attacks, I ended up switching into a different work. And what I'm doing now is largely for DHS, so I spend most of my time at CBP. Having said that, let's talk about DoD for a minute, DISA. The DISA vision is a gray network where they don't trust the unclassified network or the transport, but they want to have trusted communications across it. And the concept is similar to the concept of OneNet for transport, but with the idea that a mission owner could have a community of interest of who's entitled to see the information that they have, and they could administer the membership in that community of interest in such a way that parties can participate or not. Years ago, when we designed the IDC Bridge, the General Keith Alexander had an information dominance center at Army INSCOM, and we had the task of designing a bridge for access across the classified networks from anywhere in DoD. It was all VPN based. So you had to log on, create a VPN tunnel to the IDC, and your station became part of that network. You could do that alone, but you could participate to some degree. The concept is to be able to create an IPsec tunnel on demand based on your privileges that does point-to-point encrypted communications with any other endpoint, so that the trustworthy communications, if you will, is between any two endpoints. It's a private tunnel. The data that is exchanged is not visible to others. If one imagines for the moment a blue community of interest, where you and I are both participants, and let's say Karina was also a participant of the blue one, but Michelle is in a red community of interest. From our point of view, we would communicate freely among the three of us, but Michelle, who may be not a FEMA person or whatever, doesn't even see these endpoints on the network. So this is part of the vision of JIE for DoD. Servicemen get an identity across the whole department. When the soldier is in garrison, when he's forward deployed, when he is in training, whether he's in transit, he has access to the same information without regard to network topology, without regard to where he is. Because of this dynamic, if you will, ability to create those tunnels on the fly as part of the network management layer within his device. I didn't say that very well, but I can give you more information about this if you like. But it's something which could operate at DHS scale. DoD has been looking into this for some of the stuff they do with virtual data centers, where we have a coalition partner that we want to share information with, but then we have other regional VDCs with different combinations of coalition partners. It's very difficult and time-consuming to set up these enclaves and tear them down. A tool like this with software-driven security allows that to be done in minutes as an administrative action. But my point is, it's not segmenting the network at the transport layer. It's, in fact, in this case, a software overlay that provides you with that segmentation using encryption that's tied to identity. Did that answer your question?
Sure, we want a yes or no.
Sorry?
Thank you. We want a yes or no.
Well, it's available, and there are a number of products that do that. Some are cross-vendor, and some are CSFC certified. So they're actually accredited for classified communications across unclassified networks. Yeah, you had another question? Sorry.
To your point about that model, right, so the idea of IPsec tunnel thing, wouldn't just a blockchain, like community of interest blockchain is relevant to that blue or the red community? Wouldn't that be based on facial identity or something be equally effective?
But if you could tie it to identity, and you could tie it to the network drivers, yes. Part of the challenge with the picture that I drew earlier, could we go back to that slide? I think it was slide 11. Uh-oh. Is that within your powers? Slide 12, sorry. The key is that the trusted connectivity has to be bound to the identity. It has to be linked right into the trusted service. So in that scenario, I would argue that you want the driver for that communications, that's trusted connectivity, to be tied into your authentication scheme, in which case today it might be Active Directory or some other LDAP, and tied right into your VM. So the VM, the network layer, and the client device at the network layer are bound in, tied in, and same thing with your remote device. But yeah, but how you do the identity part is really a separate question. Absolutely. Sorry, was there a question in front?
Great. I think we're going to have to hold the questions to get to our next panel. But we will have, sure, we can give her one more.
This might be a little longer, but I know you mentioned about consumers that you know. In this case, you're focusing more about services that you provide for the government, but the government itself is providing public goods. So, in a way, everything that our government has is information about its citizens and the people in that country. So, my question is this. In terms of okay, I lost my train of thought. Identity so Operation Security, they used to say, okay, why don't you freeze your credit reports so nobody can get in there and do some charges or open loans and whatnot. But then we've got hacked, not just with OPM, but we've got hacked with Equifax. So really, to me, is if we don't get rid of our social security number, because that's basically what's almost how they can track an individual anywhere you go, either it's your social security number or your password, rather your email. There are industries out there, probably thousands of them, who can basically do a go search throughout the internet and get with that one email, they can associate it with 300 accounts on average. So think about that. If they can breach into your email account, now they can breach in all of that 300 other accounts.
Well,
so
there is a challenge with the consumer world. That's very real. There's also a system design problem. How do you identify human beings? The world today, where we use different names, different format names, other attributes, it's actually pretty crappy. I mean, part of the problem we have matching children to mothers and fathers in the Southwest is because name and date of birth isn't unique enough. Their names are typed differently. They're formatted differently. It's actually a humanitarian crisis in part because we don't have a unique identifier like an SSN that we can use across the board. So I would argue it's actually kind of there's a lot of different issues wrapped into that.
Right.
But ultimately, I don't want to take the time to elaborate a great deal on this, but the government as the steward of identity for our society can, in fact, be an issue of high confidence credentials. And it doesn't really matter if we use an SSN or something else. It could be a card identifier, it could be multiple attributes. As long as we're capable of knowing that it's uniquely identified to a human being. And it needn't be used in the private sector at all. In fact, my PIV card is not used by anybody in the private sector, but it can be used across the government as a way of identifying me as a person.
But even with PIV card, I mean, I can go to Micro Center right now and get another smart card. And if I am smart enough, I could clone your card.
You're not going to clone the digital certificate.
So
You can clone the FSCN, but you're not going to clone the digital signature cert because that's not you can't get it off the card.
So this is a great segue to our panel.